Welcome back, guys. So today let us talk about another type of circuit that is composed of a resistor and another circuit element that is called a capacitor, and we are going to solve or analyze it by using the Laplace transform. Okay. So again we have this source and resistor of 1 ohm resistance, and capacitor is also connected in series with it, which has a 1 farad capacitance. Okay. And similarly the voltage applied here is of 10 volts, and I am going to call it V naught of t again. Okay. And what I have to find out here, I have to find out the value of I t. Okay. So what we have to do, first of all let me transform it to the Laplace domain. Okay. So resistor will remain same, and here the value of resistance will be the similar one, while the capacitor and the DC voltage will be how much? This DC voltage will become V naught of S, and the value it has will be 10 by S. Okay, because of this DC constant term. Similarly here, as we have previously seen that the value of capacitor in it will become 1 over S C. Okay, 1 over S of C, as the value of C is 1. So, therefore, it will be 1 over S. Okay. So, we have this circuit now, and now we have to analyze it and write it in the form such that whatever the input will be applied, we are going to get its output here, and in this case the output is I naught of S. So, let me call output as O of S, input as V naught of S. Okay. And here we have this transfer function. Okay. So, what is basically the transfer function here? We can here see that in order to analyze it here, we can very easily see that these two are in series. So, therefore, these will be added together. Okay. So, this 1 and 1 by S are in series. Okay. Similarly, by adding them, what I will get? I can see that 1 plus 1 by S is how much? That would be S into S plus 1. Okay. So, that would be this one. So, this is basically the X of S, and here it is V naught of S, and the value of it is 10 by S. Okay, and I have to find out the value of I of S. So, that is it for this one. Similarly, according to the Ohm's law, what I know that V of S is equal to the I S multiplied by X of S. Okay. So, all the values are known here, but this one here, let me change the color here. This one is the output, which is the required quantity, while this one is the input again. Okay. So, in order to find the transfer function here, what is basically the transfer function? So, transfer function is basically the output divided by input. Okay. So, the output here is I of S, while input is V of S. Okay. So, here it would be I of S divided by V of S. Okay. And here in this formula, we can see that the value of I S divided by V S will be how much? It would be I S divided by V S will be, it will be 1 over X of S. Okay. While this is the X of S, and calculating it, I will get S over S plus 1. Okay. So, that is what, that is the transfer function, and we can write here that the value of transfer function is S over S plus 1. So, that is the value of my transfer function, which can also be written here as well. Okay. So, when any signal, let me have here the DC, if DC is applied, that would be multiplied with T of S will be multiplied by V naught of S, which is the input, and it will give me the output. Whatever the input is, you have to transform that to the Laplace domain and then multiply it with the transfer function, and you will get the output. Okay. So, after it you have to convert it back to the time domain by using the methods which we have previously mentioned, because wherever you will do it, you can see that f of t's transfer function or Laplace domain transformation is f of s. Okay. Similarly, due to the symmetry, f of s is also transformed to the f of t. Okay. So, this is due to what another property which you have also studied, and that is a symmetry. Okay. So, as we are having these quantities now, okay, sorry, this is a block, this is the transfer function, while this is the output. Input I am applying 10 by s, while at the output what I will have, this 10 by s will be multiplied with s by s plus 1, and this will be the output. Here we can see that this will cancel out and I will get 10 over s plus 1. Okay. So, that is what, that is the I of s, or the current which we have to find out. So, the value of I is s is how much, that is 10 divided by s plus 1. Okay. So, now in order to convert it back to the Laplace transform, what we have to do, we have to take the inverse Laplace transform. Okay. So, let me take it, and due to the linear property of the Laplace transform, that would be 1 over s plus 1. Okay. Now, converting it, what I will get here, it will be I of t, and here it will be 10, and it will be how much, that would be exponential of minus t. So, that is what, that is the current which is the amperes for t greater than or equal to 0. Okay. So, that is for the capacitor, and in RC circuit we can see that the current is exponentially decreasing. So, initially the current will have the highest value, but with the passage of time it will decrease and decay at the rate of minus t. Okay. Initially it will have 10 amperes, but with the passage of time it will decrease and it will give me 0 value. Okay. So, when will a circuit will give me the 0 value? Let me look this circuit here, and here we can see that this circuit will give me the 0 current value whenever this will have an open circuit, and in this case it will provide me the 0 current. Okay. So, it also satisfies the condition that for DC capacitor behaves as an open circuit. Okay. For time approaches infinity. As time approaches infinity, or for the steady state, the capacitor behaves like a open circuit, and the same phenomena has also been observed here. Okay. In this equation, the same phenomena has been observed, which is also plotted here. So, that is it for today, in which we have discussed the RC circuit, and with some more questions I will see you soon. Thank you so much, and take care of yourself.